Guided exercise number 1 says use FTC2 to evaluate the following definite integrals. And the first one is the definite integral from 0 to 2 of 4 minus x squared dx. And so what FTC2 says is, we'll do some scratch work for this one. Using the language and the notation of FTC2, our little f of x for this example is 4 minus x squared. And to use FTC2, we need to come up with an antiderivative for that function. So one antiderivative is 4x minus 1/3 x cubed. So this is one antiderivative. And so what the fundamental theorem of calculus part 2 says is, to evaluate this definite integral, we need to do capital F with 2 plugged in, because that's our upper limit of integration, minus capital F with the 0 plugged in. Okay, so now what I'm going to do is I'm going to show you how we usually record this. And so most of the time you won't do this scratch work, in part because it'll just take too long. So put square brackets and write in your antiderivative, 4x minus 1/3 x cubed. And then what we do is we write the limits of integration in the same order, but on that right edge square bracket there. And then to show the plugging into the antiderivative, so the capital F of 2 minus capital F of 0, what we usually write, and it's a good idea to use parentheses for capital F of 2 as well as capital F of 0. But what we write is 4 times 2 minus 1/3 2 cubed minus, and then 4 times 0 minus 1/3 0 cubed. And so I use parentheses to group capital F of 2 as well as to group capital F of 0. Now, the main reason that you want to do this is to make sure that that negative, that minus, to make sure that that minus actually applies to everything that makes up capital F of 0. Okay, so now I'm going to erase these arrows that I put in so that you can see the final form. If you wanted to, you could go ahead and simplify what you've got here for the definite integral, but you don't really have to, and you shouldn't unless you really have a reason to. You might as well just go ahead and leave it like that. You might want to go ahead and cross out this last thing because that's definitely 0. But that's a perfectly acceptable final answer to a definite integral. Okay, part B is the definite integral from 1 to 2 of x cubed minus 3 to the x dx. This is the second time that we're doing this, so let's go ahead and do the scratch work. So for this problem, the little f of x is x cubed minus 3 to the x. And the capital F of x, now you do have lots of options depending on what value of plus c you choose, but one antiderivative is 1/4 x to the 4th minus 1 over natural log of 3 times 3 to the x. And then you could put on like a plus 27 or whatever if you wanted to, but you don't really have to, and it doesn't really help in any way. All right, so we've found one antiderivative. So what we do is we write down 1/4 x to the 4th minus 1 over ln of 3 times 3 to the x, evaluated at 2 and at 1. Again, parentheses, 1/4 2 to the 4th minus 1 over ln of 3 times 3 squared, and then minus 1/4 times 1 to the 4th minus 1 over ln of 3 times 3 to the first power. And again, that's a perfectly acceptable final answer. So don't do more work than you have to in terms of what you simplify and what you don't. So that's part B. Part C is the definite integral from 1 to 7 of 2 minus 3x squared all over x. Now, if you look at the integrand, I can't really come up with an antiderivative with my integrand written in that way. And so what I would do is go ahead and simplify my integrand. So make a note. So simplify your integrand. Definite integral from 1 to 7. This is the same thing as 2 over x minus 3x being integrated with respect to x. So we need to come up with an antiderivative. So 2 natural log absolute value x minus 3 halves x squared. And we're going to plug in 7 and 1. Notice that I didn't write down that scratch work this time, because most of the time you really don't want to, so I want to go ahead and help you start getting in the habit of writing it this way and not doing more steps. So 2 natural log absolute 7 minus 3 halves 7 squared, and then minus 2 natural log absolute 1 minus 3 halves 1 squared. And again, you might as well leave it that way. If you wanted to, now that you can see that what you're plugging into natural log is actually only positive things to start with, you could rewrite the natural log absolute 7 as just a natural log 7. And in fact, natural log absolute value of 1 is actually 0. But it's also totally fine just to leave things the way that they came out when you plugged the numbers into your antiderivative. All right, one more of these. So this definite integral problem involves exponents, and one of them is an exponent that's in the denominator. So first I'm going to rewrite this as 3x raised to the negative 1/2 power, and then minus, and yeah, I'm going to go ahead and rewrite that second term too. It's the same thing as x raised to the 2/5 power being integrated with respect to x. All right, so let's antidifferentiate. So 3 times 2x raised to the positive 1/2 minus 3 to the 2/5 power. Why did I just write 3 there? I don't know, but it's, and I didn't even antidifferentiate, y'all. Okay, take it back. I think I saw the 3 at the beginning and was like, oh, I'm plugging stuff in. All right, so 3 times 2x to the 1/2, and then I need to antidifferentiate, because I didn't do it yet, x to the 7/5 and 5/7. Okay, let me double check that I got that. Take the derivative, and does it work? Yeah, it does. Okay, evaluated at 3 and at 1. So parentheses, let's do 3 times 2 is 6, so 6 square root of 3 minus 5/7 times 3 to the 7/5 power, and then minus 6 square root of 1 minus 5/7 1 to the 7/5 power. Okay. And again, perfectly acceptable form for your final answer. Make sure that you have the parentheses here and here so that the negative that's in front of those parentheses applies to everything that follows.